Hello and welcome to a new video from ElastiCourse. In this video, I want to show you the best and easiest way to manage Docker containers and Docker host using a Web GUI or a web interface. Now, Windows and Mac users who use Docker have ability to access the Docker GUI provided by Docker directly, which have a limited capability of managing your Docker infrastructure. For example, on Windows environment, you can run the Docker GUI. This allows you to see which containers or which Docker Compose stacks are running, and also allow you to see which images or applications are installed in your system, and even allow you to clean up or remove unused images. Now, this management GUI is okay to have, however, it doesn't have access to a lot of the components in the Docker infrastructure. For example, the volume management, the network management, and also the ability to deploy Docker containers directly from the GUI is not currently a feature. And that's why I want to introduce you to Portainer. Portainer being one easy to use and free utility to manage Docker host and even manage multiple Docker hosts using a web interface. This is Portainer.io, the homepage for Portainer Management Console. The installation instructions for Portainer is pretty simple. Just a two-step process. First, we're going to create a volume to persist the configuration files for this application. And then we're going to do a Docker run to run the Portainer inside Docker itself. So first, let's do the Docker volume. I'm going to open my PowerShell, and I'm going to create the Docker volume named Portainer data. Now, once it returned the name, that means the volume was created correctly. Second step is to do the Docker run command. As you see, Docker run -d for detach, so you don't have to see the output in here. -p for port mapping. Port 8000 and 9000 are both used to run this application. The name of the container is Portainer. Restart always mean the container will always restart itself in case of a failure or if you restart your host computer. Now let's get into storage. We have two different scenarios in here. The first one, with the -v flag, you will see directly var run docker.sock. So this is the Docker socket that run on our Windows machine, and it allows you to communicate with the Docker API. And this file gets mounted inside the container in the same path, var run docker.sock. Now the second storage option we have is the Portainer data, which is the volume that we created that contain the configuration files. So if I do a docker ps, make sure the container is running, you'll see in here Portainer is running on port 9000 and 8000. Now port 9000 is the port we use to manage the Portainer web interface. However, port 8000 is used for something else. We're going to talk about that later in the video. But for now, we need to access our computer right now using port 9000. If you're not sure which IP address your computer is using, just do ipconfig/all. And this should show you all the IP addresses from all your network interfaces. I'm currently connected by wire, so I'm looking into my Ethernet adapter all the way up. This is my Intel Ethernet adapter, and this is my IP address 172.20.0.20. So I'm gonna put my IP address in the URL and add the port in the end. This is very important. You have to define the port 9000. As you see now, Portainer asked me to create a master password. Just make sure you choose a strong password because Portainer will have a root access to your infrastructure. You do not want to put an easy password and have a compromise or attack surface using this web management. And also make sure Portainer preferably not be exposed to the internet. We're going to create the user. Now we have three different options. We have the Docker management, which is what we need in this situation, but you're also able to manage Kubernetes or agent, which is what we're going to talk about later in the video. But for now, we need Docker. So we're going to choose Docker. Just verify that var run docker.sock is going to be mapped to the container so that we can manage everything from the GUI. This should be working already, so we're going to do a connect. As you see, once I did a connect, I'm seeing my host right here, my Windows machine. I have 2 stacks running, 5 containers, 5 in healthy status. I have 10 volumes, 17 images, Just awesome way to manage a container and see everything. We also see the CPU cores, the memory, tags if you have tags for this host. Now let's go inside. We are able to see everything that we have in the infrastructure. Let's look at the stacks. These are the same Docker Compose stacks that we have running in here. Now these stacks are Docker Compose stacks, infrastructure as code scripts. We're gonna look into that also. And as you see, it might say limited because these ones were created before we create Portainer. However, these should work the same way. You can look inside any stack. You will see the individual components. And the best thing in here that it shows you the multiple listening boards at once. If you notice in here, if you look, for example, into one container, you only see one board visible. And here it shows you all the boards that are actually mapped or are actually configured on this instance. Now, also another good feature is you're able to CLI directly from here. You can run any custom commands, or you can just connect directly from here. I can do any commands I like to my containers directly from the browser. So this is awesome. Once you're finished, you can simply disconnect. Now let's go back to our images. Now, as you see in here, images are marked also with used and unused flags. There's easier way to see all the tags and everything at once in here, all the image sizes. You can remove unused images directly from here. For example, I'm not using these two anymore. Just gonna select it and remove it. As simple as that, that's how you manage Docker images on Portainer. Now let's look into networks. This is something not available in the Docker native application for Windows or Mac. You can see in here all the networks you have, all the CIDR mask, all in one screen. This is such a time saver. You can create additional networks, define everything yourself, and you have more control over what is being created. Now let's move ahead to volumes. Now with the volumes, you get to see which volumes is attached to which container or which stack, what kind of driver is the volume, and the mount point or the actual folder where the volume data is contained. Var lib docker volumes. You also get to see all the unused volumes like these ones. If you are not using them, you can simply select them and click remove. This way you are doing a cleanup on the volumes as well. So this is really nice to have. Now, this is awesome for managing the volumes, the networks, everything. However, Portainer also allow you or give you the freedom to run applications easily from here, or at least a selective number of applications using an easy weathered or easy guide. For example, I can go into app templates. As you see in here, there is a nice selection of applications in the app templates that you can run directly from here without having to go on Docker Hub at all. So it makes it easier for you to run applications quickly. For example, HTTPD is simple web server you can run on Docker. I've talked about this before. So I want to choose HTTPD, for example. I want to call this a web server. So this is a simple web server, and let's see how fast we can run this. We're going to use the network bridge. Check the show advanced option. And here you will see the port mapping directly from the browser. I think it makes it a lot easier to run this way. For example, which port do we want to put the web server? Port 80 inside the container is the default, but we can change the port mapping on our host so we can listen on a different port, and the Docker will make sure it reaches the container on port 80. For example, I want to run this HTTPD server on port 50,000. So I choose this custom port. This is going to be the listener on my Windows machine or my Docker engine machine. Now comes to the volume mapping. Inside the container, there is a path user local apache to htdocs. So this is our www root, or the folder where we should put our files so that they will be displayed on the web server. So wherever our web server files is, we should copy it to this location. So you have either an option to do a volume for consistent data, or for development purposes, if you want to quickly map local folders on your Windows or your Docker engine host, you can directly put the path in here as a bind, which is going to map anything on this folder to this folder inside the container. For example, I want to show you this free HTML5 template that I downloaded for free And as you see in here, there is an index file and several images and CSS files for a web page. So if we were to want to run this inside the HTTPD container, we can simply copy all these files to a volume upon creation and then use this volume persistently, or we can take the path for the folder in here and we make this syncing with the container data so that every time we make changes to the files in here, it will automatically be replicated on the server. So this is one situation where the bind mount versus volume would make more sense. If you are doing active development, you can simply do the bind mount until you move to production. So I'm going to take this full path and I'm going to use this as my host path. So all the files in my template folder will also be accessible inside the container in the path user local apache 2 htdocs. So that's all we really need in here. We're just going to do deploy. Now it might need to download the image first, but as you see in a few seconds, we have a web server running using the image HTTPD latest. So now we are running port 50,000 and it's mapped inside the container to port 80. We can also come here, let's copy the URL and let's change the port name to 50,000. So as you see, the template and the web server ran very quickly. Everything in here is very responsive and very smooth. And because we are not really loading these files from a volume directly, we are loading it from our Windows machine. We can simply come and edit anything in here. Let's add a few symbols and let's see, it's going to update automatically for us. So this is awesome for running development work using bind mount for non-persistent data. Now, I see in non-persistent data, but unless you remove this folder from your Windows machine, it will be persistent without a volume. Now let's take another example that is a little bit more complicated. So this is a famous game called 2048, and it's also available in the internet for free on GitHub. So I want to copy the full path for this game as well. And I want to go back to Portainer and I want to run the image again using the HTTPD. Let's call this game and let's go into advanced option. This one, let's make it listen on port 50,001. And for the container data, let's also use a bind mount. And now let's point to the folder that contains our game. And as simple as that, deploy container. Now in a few seconds, it ran, this time faster because we already have the image for HTTPD locally. So now if we change the port in the end to 50,001, now we have our video game. So this is as simple as it gets for running Docker containers using Portainer. And I think the app templates, although it has limited number of applications in here, it's a great way to run new Docker containers for beginners. And you can play with it and learn as you go. Now you can also run Docker stacks like Docker Compose templates directly from here by clicking Add Stack. You can simply copy the contents of a Docker Compose YAML file and put it in here to be deployed. So I want to show you that in a little bit, but first let's learn how to add multiple hosts using this Portainer Web GUI. So if you go back to the home, remember we had our Windows machine in here named local, and it has these running images and stacks. Now I want to show you how to add additional Docker host to this Portainer. I'm going to SSH to 10.100.200.6. This is a Linux machine that I have running. And I also have Docker Engine running, except this is an Ubuntu machine. As you see, I have Docker Engine running. Now there are multiple ways to add Docker host to Portainer. Let's go ahead to endpoint. This is where we manage our Docker host. This is our local or Windows machine. And we can add a new endpoint. Now in the endpoint, the easiest way to do it using a Docker agent. Now you can also directly connect to the docker.sock on the remote host, which is the Linux machine I'm SSHing to right now. However, to do this securely, you would need to implement TLS, which can be more challenging for some users. So I want to show you how to do it easily using the Edge agent. So this is the simplest way you can do it. We can name our remote server. So I want to call this Ubuntu 1. And in here it says Portainer server URL. So this is me right now, 172.20.0.20, port 9000. And it's gonna refresh every 5 seconds, that's fine. And then we're gonna go ahead and click add endpoint. So as you see, it generated a command for me to run the Portainer agent in my remote host. I'm not running Kubernetes, I'm just gonna go to Docker standalone. As you see, there is a Docker run command. It's very similar to the command we run on the Windows machine. There is bind mount for var run docker.sock to the same path inside the container. There is the volumes, there is the host, and also the Portainer volume data. Restart always, and these are like tokens to allow our Portainer host running right now to trust this new machine that is trying to join it. I'm gonna go ahead and copy this docker run command to run the agent in our Ubuntu remote machine, and I'm gonna take it to our text editor just to make some modification to it. Everything in here looks good except this localhost. I'm not sure what is that doing here. So I'm gonna remove this because that might cause an issue with the syntax, and then I'm gonna run the command in my SSH session to the Ubuntu server. Once I do this, if I do docker ps on this host, I see here the Portainer agent is running and it's called Portainer Edge agent. So now we should be able to get some visibility into this remote host using this Docker Edge agent. So now I'm gonna do a refresh on my home page where I see the Ubuntu one. Now it says connecting to the edge point. So now it's trying to pull the information from our Ubuntu server remotely using the communication with the Docker socket. As you see right now, I'm seeing the Ubuntu one server and the images and networks and everything specific to that server. Now the only downside for using the Edge agent is that you don't get to see the CPU and RAM information here. As you see, it's not showing. So this part is the only downside, but you can do everything exactly the same for this host. Now under endpoint, we have our local Docker and we have our Ubuntu server Edge agent. So anytime we want to deploy resources or containers or stacks on Docker, we can go back to the home and we can choose which host that we need to communicate with or which host we want to deploy resources in. So let's say I want to deploy an image using the remote host Ubuntu one. I'm going to come here, I'm going to go to containers. We only have the Edge agent right now, and we can CLI and see the stats and everything as we did before. So let's do app templates the same that we did before. And this time let's do something different. Let's do NGINX, which is also another amazing web server. Now inside the advanced option, we will get an option to define the web ports as well. So in this case, I'm just going to choose the same port because I don't have any other web servers running in this Ubuntu server. So I'm going to choose the default port 80M443. As far as the volume data, there is etc NGINX for the configuration files for NGINX, and user share NGINX HTML is the folder where our web server files should be located. We can do the same thing and copy the template to this Ubuntu machine and point it in here as well. But in this case, I'm just going to use the default view just to show you that you can remotely build containers on remote host using Portainer. To doing this, I'm just going to deploy the container. As you see, I have now NGINX running. We just need to verify the IP address for the Ubuntu server, and let's verify if this actually works. So let's go ahead to the PowerShell. I'm still SSHing to my host. Let's do docker ps one more time. You'll see now the NGINX is showing port 80M443. Let's do an IP address. In the Ubuntu server, we are running this interface right here, IP address 10.100.200.6. So this is the IP address where NGINX will be listening on port 80M443. You can verify it in here. This is port 80, it says welcome to NGINX. So now we are able to successfully deploy applications on remote host using Portainer. We also can do the same thing as far as managing the images. You see in here we have the NGINX and Portainer agent. We have the networks, the volumes, everything as we did before. We can also browse to them. So as you see, these two volumes that are used are the ones related to NGINX. For example, let's check the first one, do a browse, and this allowed me to directly communicate with the volumes, upload and download directly from the browser as well. So this is the index file that you see in here. The default will come to NGINX file. I want to come here, I want to remove this file. And I want to upload directly from my template folder here, the index.html file. Of course, it's not going to work properly unless you upload all the images and CSS files. But just to show you the ease of using browser-based volume management, now if we go back in NGINX, this is the badly formatted HTML5 that lacks all the styling and all the images. And this is how easy it is to manage multiple Docker hosts using Portainer. Now the last point I want to touch on in this video is Docker engines downloaded using Snap Package Manager. So if you look into the statistics for Docker usage, you will find that the top 4 operating systems where Docker is used are all Ubuntu operating system. So Ubuntu is one of the most popular operating systems where people use to run Docker. Now the important thing to keep in mind is if you install Ubuntu for the first time, you will be given an option to install Docker as well. And when you install Docker this way, it creates some complication because the path and directory for the files are different from the native installation instruction for Linux. And this will create an issue because Portainer agent will not be able to find the socket file for Docker and also the volume location. So I want to show you this in action using this new installation for Ubuntu server. You will usually get a message like this saying there is a new update available for the installer. And if you choose to go ahead with the updated installer, this will allow you to install whatever applications you want from a pre-populated list that includes a few programs including Docker. So let's wait and see what options we're gonna get once the server reloads. I'm now getting ability to download Docker directly from here, which is convenient. However, as you see in the top, this is featured server snaps. So everything you download in here is using Snap Package Manager, not EBT and not the official repository for Docker. So I'm gonna go ahead and choose Docker and I'm gonna go ahead and do done. This way the server will install Docker from the Snap store, and then once this is done, we'll be back to see what is different. So now once the server is running, now I want to SSH to it the same I did with the first Ubuntu server. I'm gonna do SSH admin2 is my username, 10.100.200.8 is the new Ubuntu server that we installed Docker using Snap. Now once I did Docker PS, now I'm able to see my running containers or lack of. Another way to also verify that Docker is running inside Snap is to do sudo snap services. And as you've seen here, docker.docker-daemon is active in Snap, whereas on our other server, sudo snap services, we can see in here there is no Docker daemon. So this is the difference between Docker installed using Snap and Docker installed using apt package manager. Now to show you the issue in action, I want to try to add this second Ubuntu server where Docker installed using Snap to my Portainer server so I can manage this host as well. We're going to add another endpoint, which is also an edge agent. Our server IP did not change, the port did not change. We're just going to call this Ubuntu 2. And now we are getting another token so we can add this new host. So we're going to do the same thing. Docker standalone, copy the line, take it to the text editor first. And let's remove this word localhost. Copy the same thing again. And let's try to push this to our second Ubuntu server. So this is Docker run, everything. Downloaded the image. And now as you see, error response for daemon error while creating mount source path var lib docker volumes. Its read-only file system is trying to create var lib docker volumes, which should be already existing. So that proved my point that the paths are different, therefore these commands in here, the bind mount commands, are not gonna work. And to fix this, we just need to reconfigure the bind mount to the correct socket file and volume file. For this, I recommend you download the tool I talked about before, which is Locate. So in any Linux system, you can install a utility called Locate, which help you find files and give you the full path for it. So I want to update my repository, sudo apt update, and then Once this is done, I'm going to do sudo apt install locate. This is the name of the utility. Should be fairly simple. Now, by using the third command, which is sudo update database, this locate plugin will kind of index the whole file system and know where every file is located. It takes a few seconds. Once this is done, we should be able to find any file. So the first file we need to find is the socket file. It's the most important file. So I want to locate docker.sock. And as you see in here, it's running in a different directory. Instead of var run docker.sock, is directly on run docker.sock. So this is the first difference. Now the second thing we need to change is the volumes. This is very important because volumes management is a big feature of Portainer. So we can try something simple. Let's try to create a fake volume so that we can find the location for it. So I want to do docker volume create test volume. So once the name is returned to us, test volume, that means the volume has been created. So let's do one more time, update database, make sure it's indexed. And then let's do locate test volume. Once I do this, you will notice in here the test volume and the volume location is totally different from the native Docker installation. And this time it's var snap, because it's a snap package, docker common var lib docker volumes. So this is literally where we need to point our Portainer agent. I want to copy this. This will be, instead of the default path, this will be the snap specific path. The token, everything else stay the same. Now let's copy it again and let's do one more time, docker run. Now it's complaining about the Docker was already created before when it didn't work. So what we can do in this case, if we verify docker ps, there is nothing running, but we can do the command docker ps space -a. This one show even the ones that failed to create. You will see in here docker edge agent was created 3 minutes ago, but it's not gonna work because it's pointing to the wrong directory. I want to do docker container rm, and I'm gonna point to the container ID in here that I want to get rid of. Now we should be good. If I do docker ps -a one more time, I'm clean. So I want to do docker run for the third time. As you see now, it did not complain about the path not being correct or trying to create a directory. So now everything should be straightened out. Let's go back to Portainer and let's go to home. Now we see our Ubuntu 2 server also running the same way. There is the edge container, and we can also do the same thing as far as managing the networks, managing the volumes. You see in here that test volume that we created to find the location. We can now delete it. And we can also implement the same thing, NGINX, on the third Docker host, which is our second Ubuntu server. For the port mapping, let's do also port 80 and 443. And then let's deploy the container. This will download the NGINX image to our Ubuntu server, and we'll run it on these ports. So now we should be able to go into 10.100.200.8. So now you'll see this is NGINX running on our third Docker host on the Ubuntu 2 server, running on Snap. Now finally, I want to show you how you can deploy also Docker Compose tags directly using Portainer. I went to Docker Hub and I found this simple Docker Compose file for WordPress. And if you're not familiar with Docker Compose, this is infrastructure as code utility where you can build infrastructure components or images, applications to talk together using YAML file or configuration files. So as you see in here, this is the YAML file format. There's two services running in this stack. There's a database that power our web application. There's simple database being created on start, which is called WordPress, username, password, root password, and then the WordPress image itself, which is the web server, the PHP, contains the WordPress image latest, running on port 8000, and it's being passed the environment variable for the database so they can talk together. And finally, there is a volume for the database data inside our system, and it points to var lib mysql. So this is very simple Docker Compose file. I want to copy it I want to go back to my Portainer, and let's choose to run this maybe on the Ubuntu One server. This is one of the remote servers. So let's go inside stacks and let's do add stack. Let's call this our blog. Since this is WordPress, you can either upload the YAML file directly, or if you don't have it, you can just paste the contents in here. As you can see, the formatting for the file is perfect in here, almost like you're using an IDE. So everything is marked and well formatted. And this is all we need. Once we give the name and the stack configuration file, we can directly deploy the stack. So this will download the WordPress image, MySQL image for the first time, and then we'll create the database and do all this stuff for us. And just by the end, we should be able to access our host directly on port 8000. So as you see in here, stack successfully deployed. So now we should be able to access our server, Ubuntu One server in here on port 8000. So I want to change the port in the end to 8000. As you see, once I do this, I'm now getting into the WordPress first time setup. As you see, this was very simple to run using the Docker Compose, and in just a few seconds, I'm able to run a web server and a blog using Portainer on remote host. And this is the power of using Portainer to manage and run multiple Docker hosts and deploying application and stacks in between them remotely from just one location. Thank you for watching.